Hi, everyone. My name is Kyle Bannon. I'm a C&I Sales Engineer for Fortress Power based out of California. Thank you very much for joining today. We got an exciting webinar in our Nano webinar series, our C&I webinar series here with Fortress Power. We're going to talk about some exciting stuff. We're going to talk about really specifically the new eSpire Nano product line, and even more specifically, how you can, get the tools to sell it yourself better, right? We're going to talk about First, we're going to talk about Fortress's view on the C&I market and some of the other products we have around the Nano and why it fits into the niche that it does. We're going to take a huge step back and talk about what is an energy storage system and how are we selling that value to customers. We're going to talk a little bit about the different strategies that people use to get value out of their energy storage systems. And then finally, we're going to dive right into the meat and potatoes of what is the eSpire Nano. We're going to have future more technical webinars. So if you're focused on single line diagrams and how does this fit into your specific sites, please stay tuned and sign up for future webinars that we have in this series. They happen about every 2 weeks. But this one is going to be focused on the sales side. This is going to be focused on how do we show that value to customers and how can you use this new eSpire Nano system to secure your energy, as is our tagline here at Fortress Power. Just a little bit of housekeeping before we get started. If you have any questions, use the chat and Q&A function in this GoToWebinar software. We have someone from Fortress Power screening questions and sending them forward. So throw anything you got and I'll look at those after the presentation. We'll do a short Q&A as well. Without further ado, let's jump right in. If you're not familiar with Fortress Power, we are an LFP energy storage company. So we do strictly LFP, lithium iron phosphate chemistry. We have our residential business with our residential product lines, but specifically I work on the C&I team, the commercial industrial. And the way that we look at the market is that there's a gap, right, between residential scale and utility scale. Call it, 50 to 60 kilowatt hours up to 5 megawatt hours, where there are a ton of applications, right? You can see some of them at the bottom: warehouses, quick serve restaurants, industrial facilities, schools, churches, you name it. So the thing that makes it kind of tough is that there is not really one good all-in-one product in that green bubble. So that's really where Fortress comes in. We want to offer products that fill that niche and even to some extent extend beyond it. We want something that's turnkey, and by that I mean you put these things on a concrete pad, you hook up the connections, and they're good to go. Everything inside comes pre-wired. But you can see our product lines and, whether they're FEOC or non-FEOC. FEOC is a huge thing right now, especially when it comes to, are you going to get this 30% tax credit for your energy storage systems? Just know that every manufacturer across the market is coming up with these same things, right? How can we make sure our systems are FEOC compliant? So keep that in mind. The Nano as it is today is not FEOC compliant. But it will be certainly by fiscal year 2027 next year. We're actively working on ways to make that a FEOC compliant product. But for now, we're going to be focused on that bottom left product that you see, the Nano, which is a non-FEOC system. Just to give you an idea of some of the recent projects Fortress has done, not necessarily with the Nano, but with all of our commercial projects. I mean, small companies, big companies, private, public, small 3-phase 208 to huge 480 volt like water treatment plants. Fortress Power has done this all, and really just in the last year or two. And this is across the nation, from Hawaii all the way to New York. So we feel that if we can work in these super stringent jurisdictions in California for commercial projects, we can do this just about anywhere, and that's been the case. We've got all the certifications to make that happen. To give you an example of some of the stuff that's in the ground, some of those sites that you just saw. We've got Masonic Temple on the far left, that's in Honolulu. We've got one at a Chick-fil-A in Oceanside, and then another one in Malibu, California. That Malibu site, I'll actually show you some of the strategies that they use to help save money on their power bills or provide power in an outage. And we'll get into all those use cases in just a minute, but these are just some successful installs that we've had in just the last year or two. And this is on the larger scale, right? This is more getting into the almost utility scale systems we have. Whether it's fully off-grid, like you see on the one on the left, or for grid-tied demand reduction, 3 megawatt hours or so of energy storage. We've seen and done a whole lot in the short time frame that we've been in the commercial market. I mean, just to give you an idea of the California pipeline, this is out of date, even this is in the last couple months, but the types of customers that we see, you can see a lot of education. 43 out of 209 sites are some type of education site. city government, libraries, water, wastewater treatment. All of these customers can find ways to use an energy storage system, mostly to save money on their power bill, but some are looking for outage protection. These are the types of customers that are buying energy storage systems right now for varying reasons, right? So I'll give you kind of breakdowns of who these customers are and why they like the energy storage systems. But again, this is just to give you an idea of just our California pipeline, the types of customers that are looking for these energy storage systems. Now, again, like I said, let's take a huge step back and level set. When you're talking about a residential energy storage system, it's practically commoditized, right? It's really plug and play. The rules, the standards are pretty set. There's not a ton of configurability. That's different on the commercial side. I always say, if you've done one microgrid, you've done one microgrid. They are their own special snowflake puzzle that we need to solve, right? So again, let's take a huge step back and break this down into components. What exactly is an energy storage system? Well, first and foremost, there's the power conditioning system, or the battery inverter. It has many names, but it is essentially, if I'm going to use an analogy to a car, it's the engine in your car. It's what dispenses power to the wheels that makes the car go, right? So when people think of a battery, right, they think about energy storage, but realistically, the inverter is just as important, if not more important, than the cells themselves. Next, you have the actual battery itself, or energy storage, if you want to sound like you know what you're talking about, right? Energy storage, if the PCS or inverter is the engine, the battery is just the gas tank. It's how much, the engine, we can run the engine at 100%. How many hours is determined by how full your gas tank is and how much gas it can hold. So it's super simplified analogy, but where the inverter dispenses power, that's instantaneous. It's not over time. Energy is literally power over time, multiplied by time. So when you see kW, which is in power, and you see kilowatt hours, which is energy, you got to know what you're talking about. Again, that's the first thing if you know what you're talking about, you can distinguish between kW and kWh. So engine, gas tank. And then the last, probably most important bit, especially in commercial energy storage, is what we call the controls, or the energy management system, right? Closest analogy, if we're talking again about the car, is your power steering and your cruise control, everything that makes all of these different pieces of hardware work together to give you the smoothest ride on the planet, right? So having all these things in an energy storage system is important as well. So when you're evaluating energy storage systems at large, try and think about it in these three categories. The engine, the battery, and the PCS, they are commoditized type products. You want to get the stuff that's been in operation for the longest period of time, look at the failure rates. But the energy management system is something that you're going to get a mixed bag depending on who you talk to. And I think that's one of the values that Fortress Power brings, is we have our own energy management system, EMS software. It's called Keystone. We'll get into that in just a minute, how exactly that helps to coordinate everything. But again, I wanted to take a step back and just break what is an energy storage system down into these three parts, so you can use that analogy to your customers as well. I think that helps to simplify things, but not overly simplify what we're trying to accomplish. Another major thing that we need to level set on and take a step back on is, what is a microgrid? And I get this, this term microgrid is used super ambiguously every time that I've seen it used. It depends on who you ask. So depending on who you ask, it could be the facility itself, something that can operate independently of the grid. Yeah, I could see that in certain cases. Some people think it's the equipment itself, right? It's the battery, it's the solar, it's the generators. They all come together to form this microgrid. Or some people think like a virtual power plant, right? Something that can generate power independently of the grid and send that power back to the larger grid. That's technically a microgrid. I could see, justifications made for all of those, but again, it gets a little confusing, ambiguous. It really comes down to this. In general, a microgrid has some way to generate power, right? And then we're talking really the facility itself and the equipment that goes on the facility. Has some way to generate power, some way to store power, whether that's a battery, a flywheel, capacitor, you name it. And it coordinates all these different technologies together to use that power intelligently according to the end user's goals. Now that sentence is really purposefully worded because, like I said before, you've done one microgrid. You have to get to the bottom of what they're trying to accomplish by adding battery systems. So from a sales engineer perspective, the first question that comes out of my mouth when it comes to evaluating different projects and is it a good fit for the products we have is, what are you trying to accomplish? Do you want backup power? Do you want to save money on your power bill? There's all different ways that we can get value out of this, but what value is most important to the customer? What are they going to put a premium on? So that's really what we're selling, right? We're trying to, ultimately, most customers are trying to save money in some way, whether that's on their power bill or save fuel costs from not running a generator. The dollars is what really drives these projects. In a lot of cases, adding resiliency, they can put a dollar amount to that, or the peace of mind that they get from that is enough to push the economics over the edge. So adding resiliency in some cases, and in all cases, reducing complexity whenever we can. And by that, I mean, in a lot of cases, we go back to the car analogy, energy storage providers, different OEMs will say, okay, you can get the battery and the inverter from us, but you got to go get the controls, the EMS from someone else. Or likewise, they say, hey, we'll sell you the microgrid controller and the software, but you got to get the battery and everything and make sure it integrates properly. That's the last thing that a lot of customers want to hear. They want a one-stop shop approach. They want one hand to shake or one throat to choke, depending on the connotation. But the reality is they just want to deal with one company, not 3 or 4. And that's something that Fortress does really well, right? Because we have the energy management system software in-house, we're taking high quality products, inverters, batteries, and pairing them with our software and then selling it as a one package. The analogy I like to use is it's the difference between building your own computer and buying a MacBook, right? You can spec out all the different parts within your computer, GPU, CPU, make sure all the specs line up, make sure you're covering all of those warranties and the conditions that are required within them. Or you can go to one company who just sells you a computer and you get everything through them. And they're the buffer between all the manufacturers that put their equipment in. That's the way that we're selling energy storage equipment. Is we are a one-stop shop. We're the buffer between the large OEMs like CATL, BYD that you can't get on the phone. They're based in China. You want to call an American company based in Philadelphia or based in Los Angeles that can help you, sell and size these systems as appropriate. But at the end of the day, this is what we're selling to the customers, right? Saving money on their power bill, potentially reducing complexity if it makes sense and if it makes sense to them, and reducing the overall complexity of the actual install, the turnkey install. To give you an idea of some of the customers that I see, in the last 4 or 5 years that I've been working for Fortress, the same customers pop up, right? So if you have relationships with these type of customers, we'll talk about what the process and how to get more information and actually sell. But these are low-hanging fruit in my eyes. Schools and municipal buildings, especially in California, there's a lot of, Title 24 construction requirements. Essentially, any new construction needs to have solar, needs to have batteries. Title 24 is a bear in and of itself. It's kind of a solution looking for a problem. But if you have Title 24 questions, throw them in the chat and I can address those specifically. Long story short, schools, municipal buildings, if they're adding solar, they're likely going to be adding batteries because they see the writing on the wall. They're only going to add more load over time. Their power bills are only going higher. They need to come up with some strategy to help mitigate that cost increase. So with public grants, with different tax schemes to be able to get these projects penciling, we found that schools and municipal buildings is, again, just low-hanging fruit. Car dealerships, again, they're adding EV chargers. They're adding a bunch of load to their facilities, and we haven't talked about demand charges yet and the strategies around them, but they get hit with these demand charges that say if you use above a certain threshold, you're going to get charged an exorbitant amount of money for your power. That's essentially a signal to say, hey, don't use utility power as often, or don't use utility power, above a certain threshold. Car dealerships are a perfect example of that, with all the load they're adding in a way to save money on their power bill. Agricultural facilities, again, they get hit with crazy demand charges. I'll show you a map in just a minute of demand charges across the country, but some of the more remote places relative to major cities and transmission lines get hit with these huge demand charges. So great, let's add a battery there to save those peaks and help cut, sometimes cut your energy bill in half. And agricultural facilities as well, they, more than most customers, can put a dollar amount to, hey, every time this pump goes down or every time the power goes out and I can't feed the hogs or whatever it is, I lose a ton of money, and they can discreetly get that dollar amount. That is a good use case of saying, hey, we're going to help you save your peaks and save money on your power bill, but what are your critical loads? What's your backed up loads that you absolutely need in an outage? And let's size the system to at least cover that. So combining those value streams, again, low-hanging fruit. It's easy for these customers to say, yep, that's a no-brainer. Just 3 more profiles, and please, this is not all-encompassing. These are just the ones that I tend to see more and more often than not. Quick service restaurant or retail locations. They're also, like everyone, getting hit with crazy rate structures, and depending on how that facility itself operates, maybe they, if it's a quick service restaurant, right, from 5 to 9 in a lot of rate structures, that is the most expensive time to be using power. And when is dinner time? Right smack in the middle of that, right? So how can we you get maybe a small solar system and a battery to just offset those 5 to 9 peak times. We're seeing a ton of QSR locations doing that. Manufacturing facilities, you're going to see a trend here, using more power, high spiky load profiles from shift work that we know when these shifts are going to hit. We know when the power is going to spike. Perfect use case for a battery to reliably, save that peak, know what the power use is over time, and charge the battery back up so that you can use it the next time hits. And then last but not least, municipal buildings. I'm seeing a lot more. It's really more a multi-tenant apartment buildings are trying to do this more and more. It's the concern there, I should say, the barrier there that we often see is they're all individually metered, and it can get a little hairy in terms of microgrid and coordinating all the different circuits to the main meter itself. But we've seen a lot of multifamilies saying, hey, we're going to offer this as a service to our tenants. We're going to have a PPA essentially that will provide power, and you'll get a reduction in your bill, and we're going to just share the profits that we get from saving money on your power bill with everyone. So if you have, like I said, connections with these types of companies, keep them in mind as we go through this presentation and ask questions. Hey, I've got this type of customer. How do I really get through to them? What do I need? Hopefully we'll cover it, but throw it in the chat if the questions arise. Okay, before we dive into the actual strategies themselves and what I frame to customers as the different ways that you can get value out of these systems, I want to talk about what's called the load profile. Now, load profile and what the next slide we'll get into, energy mix, are two distinct things, right? The load profile is literally how they use their power over time. Now, I've separated out in this slide right here, the load profile is up top and the actual energy mix is down low. Now, the scales are a little bit different, so don't let that throw you off, but essentially the black line is how their main meter is seeing power, and the bottom is a snapshot from our energy management system software that says, okay, here's where the power is coming from, and here's how we're divvying it up based on what the price of power is at any time. So you can see in this case, we'll talk about peak shaving, we'll talk about time of use, but in this case, the customer said, okay, I don't want to ever pull more than, it looks like about 10 kW. I don't want to pull more than 10 kW from the grid at any time. The battery says, great. If we have a CT on the main meter that says, if this goes above 10 kW, discharge the battery to make up the difference. And that's what you see here. This is overnight before the sun actually comes up. So the battery's doing all the work overnight, sub 10 kW till when the shifts start in the morning, and then boom, the battery is already saving peaks. But when you're talking about selling this to your customers, right, this load profile in conjunction with what their rate structure is going to determine the energy mix, and therefore the sizing, and therefore the cost of the energy storage system. So I think a lot of times customers I work with want to say, like, okay, here's my power bill, here's the total, here's what my demand is, how do can you give me a return on investment for this type? Can you run it through a model to tell me how much money I'm going to save? Without the load profile, it's nearly impossible. And the reason is because it's so nuanced. What we're going to do is feed all this info back into our energy management system modeling tool and say, okay, these are the parameters, and then the algorithm chooses when to charge and discharge based on those parameters that we set. So I want to, again, drill down into, without this load profile that you see up top and without the rate structure that you see at the very bottom, it's nearly impossible to spit out like a financial pro forma statement or a payback period analysis of these things. Now, that being said, if you do have that, if we know what the solar is producing, if we know, what the rate structure is, if we know how this facility is going to be using power over time, we're going to be able to get, and assuming that it's not going to change for the future, we're going to be able to model, hey, without a battery, without solar, this is what you'd be paying for power. But now that you add this in and look, this is how it's going to charge and discharge based off of all this, that you can look to save X percentage on your bill. This is the rate of return that you can expect. We'll get into that in just a second. I'll show you an example bill, and we'll talk about, hey, when you talk to your customers, what kind of information should you be asking for? We're going to go through an example bill, and I've highlighted exactly where I look to determine if the project's even worth, looking at further. But let's get into the strategies themselves that customers are using to actually save money on their power bill. There's three main ones we're going to talk about too. The three main ones are time of use, energy arbitrage. That's as simple as we charge when electricity is cheap, and we discharge when electricity is expensive. Just that simple. What I've shown here, this is an article from New York Times, I think from 2024. This is just from 21 to 24, how California's energy mix has changed over time. And what I want to highlight is that tail end, the batteries, right? That 5 to 9 p.m. period when everybody gets home from work, everybody's running all their appliances, and most importantly, the sun is going down right at the time when the peak demand is happening. If you're familiar with the duck curve, that's what we're looking at, right? So batteries have been instrumental in saving the end of the duck curve, not having to rely on the grid power because the solar power is going down, having the batteries offset that. I think I saw a chart of this recently that it's only gotten exponentially more covered by batteries in that 5 to 9 p.m. window. So that's the easiest way for you to sell this to your customers and say, hey, are you on a crazy time of use rate? Are you getting charged, crazy rates from 5 to 9? Well, when does your facility operate power? Does it happen to be between 5 and 9? Perfect. Let's potentially look at a battery to see how you can save money on your power bill here. So that's time of use energy arbitrage. And again, this just highlights the peak output. This is throughout the year, right? I like to show this because if you guys remember the eclipse in 2024, that it actually put a relatively large strain on the grid. We had no solar power for about an hour or so, batteries had to kick in to help with that. But this again, I'm going to look to update these numbers for 2026. I can only imagine they've gotten worse. The next type of strategy is probably the most lucrative and probably the most common strategy that I see is peak shaving. If you're not familiar with peak shaving, essentially, like I showed, you have spikes in your load profile. If they're just short duration spikes, 15 minutes to an hour, perfect for a battery to come in and say, hey, okay, I'm not going to let the utility ever pull more than whatever my projected baseline is. So that's what you can see in this graph down here. The green is battery discharging. Yellow is PV generation. The load is spiking, but since there's PV, the PV is being used to offset the load plus the battery. The utility, we're never even really pulling from the utility in this case. So that peak shaving, again, it's super dependent on what that load profile looks like and if you're getting hit with demand charges. Demand charges are that threshold that say above a certain kW, we're going to charge you $15 per kW. This is a map from NREL, again, a little bit out of date. I think this is from 23 or 24, but this just shows the breadth of demand charges across the country. Now you can see California has some of the highest demand charges. That's, I think, partially why the battery market and solar market does so well there. Is it is the most, best return on investment in the area. But you look, there's pockets all across the country. I mean, Colorado, Utah, places in Illinois, where if you look, my rule of thumb, this is a good thing to soak up here. My rule of thumb is anything above $20 per kW in terms of demand charges, regardless of the load profile, we have to take a look at that 15-minute interval data and say, okay, if we use the microgrid controller and EMS software to offset that, how would we be saving you money? So anything above $20, we should be looking. $15 per kW, around there, you really need to be looking at, do I have a backup power component or a virtual power plant, adder that I can get extra value out of? Anything below 15, it can get a little tough, but some of these large manufacturing facilities, they use enough power that it warrants a battery system. But you can see on the chart, the top 10 states here are the max is well above $20 per kW. So if you find the right customer, it may not even matter how they use their power. If they're getting charged $51 per kW, that means every time they just even go a little bit above it, they're getting absolutely screwed. And what I want to show you is this bill, right? This is an example bill. This is an automotive manufacturer in California. This is much larger than what an eSpire Nano would offset, but I wanted to use this for illustrative purposes because it's a good example of what, peak shaving and how we can use the batteries to offset cost here. This is straight from the bill. This is a TOU rate from SCE. What I'm looking for is that demand rate in kW times dollars, right? And specifically, what's that dollar amount? Remember I said $20 per kW, that's the, sniff test. Well, this has some of it, at certain times of the year, it's above that 20 kW, but certain times of the year it's below. But the other rule of thumb that I use is if over half of your bill is made up of demand charges, in this case, it's 65% were demand charges and the rest were just normal, time of use usage charges. You need to be looking at a battery for peak shaving purposes. This was, again, a perfect example, and where the demand rates were right around that $20 per kW, and their demand was 65% of their bill. Yeah, let's get some interval data and let's feed this into our model to see how it spits out. And that's what you see here, right? So their demand cost, baseline before adding, this shows PV only and battery and ESS. So before, they're going to be paying $170,000 a year in just demand costs. After, if you were just going to do PV, yeah, you save 50 grand a year. That's pretty good. But if you're going to add PV and battery to this, oh my gosh, you're saving nearly $140,000 a year. So, payback periods of 4.2 years after tax with some of these things. This is a no-brainer for this customer. Again, this is a little bit larger system than what we're talking about for the Nano, but the economics still apply. If demand charges make up at least 50% of your bill, and your demand rate is $20 per kW and above, let us run this analysis for you and say, okay, what is your rate of return going to be with PV, without PV? This is how you sell these things. Does it make the dollars to actually make sense for me to put in, right? That leads me to my Keystone EMS portion of this. Now, the software is so important for these because, again, one, it is not something that's standard across equipment. You're likely, in so many cases I've seen, you're going to be using third-party EMS. But not with Fortress. That is all in-house to Fortress, the hardware, the software, and the engineering support to design and accomplish these projects. So why is the energy management system so important? Well, it is that intelligent cruise control or power steering software that coordinates not only our equipment, but things like third-party PV inverters, things like generators, things like utility signals for virtual power plant, puts it into all one dashboard, one ecosystem that you can see and monitor how your site's doing over time. Not to mention all the backup power and integrating all these different technologies for that application. The goal of this system is, again, what is your rate structure? What is your energy mix? And how can we dispense or charge these different assets based off of what you're trying to accomplish? So to give you an example, this is that site in Malibu, that eSpire mini site that I showed on one of the first slides. They are a perfect example of a system that has used their system for all the different value streams that they can think of. It's on the left, you see it's a peak shaving system. They're like sort of an agricultural facility in a way. They have these pumps that run pretty regularly. So perfect. The battery's going to peak shave those pumps and mitigate any sort of demand cost that potentially comes from that. Additionally, this is in a demand reduction program or energy services or virtual power plant program that in California essentially says, hey, we're going to send a signal into your software that says, hey, there's a ton of power demand on the grid right now. We need to take some off. Please dump your battery, sell power back to the grid to take the demand off. Great. That's what you see on the right side. Once it hits that 7 to 9 p.m. heavy window that's contracted with the utility, it's just automatically going to dump. But what you can see also is it's peak shaving at the same time. You're not necessarily selling the full the way the contract works is the utility says, hey, we send any excess capacity that you have. It's not a contracted amount or time period. The time period is contracted 7 to 9, but you can see it's also peak shaving during that period. So even though you're getting to cut a check from the utility for this, you're still covering your peak shaving obligations from the start. So this is, again, a perfect example from a financial perspective of stacking value streams. And then from a backup power perspective, they're in SCE, they're in Malibu. When the fires hit, they had to cut off all power to the area, right? So here's an example of when the utility, or even for high winds in Malibu, they'll cut the power off. But here's an example when the power went out at point number 1, 5 a.m., power goes out, immediately battery just switches over, and it's like you never even know. It's like a 30 millisecond switch time. That's going to track for the Nano as well. It hovers until the sun comes up at 0.3. Meanwhile, it's still peak shaving. You can see the load profile from those pumps that we talked about before. Once the sun comes up, immediately the solar takes over. We're not discharging any of the battery. In fact, we're immediately starting to charge the battery back up with any excess solar. That shaded area that you see, that's what the loads are, or that's what the batteries are consuming. The yellow is what the PV is producing. So that difference is what the load is on the facility at that time. So once we get the battery charged back up to like a 95% state of charge, immediately we're going to curtail that solar. We're only going to dispatch the solar to what the load is. So now we're just load following with the solar. Number 5, utility power comes back on immediately. The battery doesn't have to think about this. It just dumps the power to the grid because that's what's most financially, it makes the most financial sense at that time period, at that rate structure, at that use of power. And then there you go. Once the sun goes back down, number 6, we're back to normal operation. We're going to offset that shoulder period load and demand charge mitigate. So again, if you can think to your customers, don't just put them in one box. Don't just think, hey, We're going to save you a ton of money on your power bill. Granted, backup power can get a little complicated in terms of the electrical design, but I want you to go to your customers thinking, hey, there's like 3 or 4 different ways we can wring value out of this energy storage system. Let's look at how you use your power, what you're getting charged for it, and then maybe we can go from there. And I think that's a good segue into our in-house tool, our Keystone Designer modeling tool. If you send us 15-minute interval data, ideally for a year, but any time period with big caveats and assumptions we can work with. If you send us how your facility uses power, 15-minute interval data, and you send us the rate structure that you're on, we can spit out this energy tool-based style analysis where it says, okay, here's what you would be paying before a battery and solar. Here's what your expected cost would be based on your usage and rate structure. Here's your rate of return. Here's your payback period. This is what sells projects, guys. So if you like go through the sniff test and you're thinking, okay, I think we need Fortress to look at this a little closer just to spit these numbers out, we'll happily do that. There's no cost associated with that. In fact, we may even have some tools to give to you as beta testers as we roll this out. But for now, you have to send us this data. It takes a couple days, and then we'll send this back, this pro forma cash flow statement to you. So that is, I think, my summary of how you should be pitching the value to your customers here. It has had nothing to do with the eSpire Nano specifically, right? That is just talking about how we are going to be selling these commercial batteries. Now, let's get into the Nano. Where does the eSpire Nano fit in? You remember from the very beginning of the presentation, we had this chart that, okay, the Nano is really on the, like, I would call it high-end residential, light commercial, resi-mercial. I've heard that term thrown out a bunch. It's really, truly anything that's 3-phase 208 or 480 volt. So we're seeing more and more of the smaller 208 systems, right? Under 30 kW of demand, but they're getting hit with crazy power bills. This eSpire Nano is absolutely perfect for that. It's very similar, how do I say, form factor that you'll see on, out in the market today. You have a hybrid inverter that you can mount either on the outside of the battery cabinets or you can unistrut mount it. We can pair multiple battery cabinets to a single inverter. I think up to 180 kilowatt hours to a single 60 kW inverter, but we'll get into the sizing in just a minute. But it's really these 2 building blocks, the inverter, the hybrid inverter itself, and the DC block. Again, this is just for 3-phase applications. It can do some 3-phase, split phase 240. If you have those type of projects, let us know, but it's mainly designed for 480 3-phase and 208 3-phase. All the same, applications that we talked about before, this thing is going to support. One major difference between this system and our other commercial systems is this does not necessarily need to come with a microgrid controller. That advanced EMS control really comes into play with PPA projects, any virtual power plant projects. But for the most part, if you just need simple peak shaving or you just need to set a time of use window, you don't need our microgrid controller and EMS software, which is great. It saves a ton of costs and it simplifies everything. But that's also the best part is if you do need it, it's a simple slap on. We'll add the hardware and software costs and we're good to go. Some cool things about the inverter itself is it can take DC coupled solar. It can take AC coupled solar. It has a generator port. And it also has a load shaving port. So if you say you have, you're using this for main panel demand mitigation, you're just hooking this up to the main panel with an AC conductor. But say you have like an air conditioning circuit that you don't want to run, or some high power load, an elevator, for example, that when the grid goes down, you just don't even want to cover that load. If you plug that into the smart port of the hybrid inverter, we can shed that load in an outage and say, okay, let's remove a ton of unneeded demand in certain situations. And that's all controlled just by the software of the hybrid inverter itself. So this Nano hybrid inverter, like I said, it is ubiquitous in the market. You'll see very similar things to this, but the software support that you get from Fortress and the ability to pair that with our microgrid controller is the real bread and butter here. Let's talk about the different configurations that you can fit this inverter into, right? You got 30 kW for either 208 or 480 volt. Or we have a 60 kW option that is just 480 volt. Now we can parallel multiple of these inverters and we'll get into that in just a sec, but just know your Lego building blocks here are 30 kW at either 208, 480 and 60 kW at 480 only. Each inverter does come with its own set of MPPTs. So depending on which model you get either 3 or 4 MPPTs. Something to note, every string that gets plugged into the individual MPPTs here needs to be identical in terms of voltage, in terms of panels. Identical strings need to go into these MPPTs. But you can charge and discharge up to, for the 30K, up to 33 kW, just a little bit of overage there. For the 60K, it is capped at 60. We do have some rated AC outputs that can overload for very short amounts of time. That overload protection is nice, especially when you're talking about backed up loads and things with inrush current. So depending on which model that you get and what voltage is selected, we'll have different rated AC outputs for different amounts of times over that as well. Pass-through. Each inverter does have a fair amount of pass-through. So for the 30 kW 208, you're talking 52 kW, but for the 60K 480 volt, you're talking up to 120 kW of grid input that's passed through and charged. So a lot of flexibility here. You don't have to rely just on the inverter itself to cover all this stuff. You get a fair amount of pass-through there. And then I mentioned the smart port. That smart load port load setting is going to be used for either a generator or AC coupled PV or that smart load. It's the same port that's going in. So just know you can only use one at a time. You can't both do AC coupled and generator. It's or. Now there's other ways to set it up to coordinate these things, but if you're going to use a smart port, you have to select one of those. This is just an IKEA style or Lego style breakdown of everything that you get when you purchase an eSpire Nano inverter. There's not a lot to it, folks. It's a wall mount bracket. It's a handle itself to actually maneuver the thing. It is relatively heavy, but yeah, you'll get these. It's one of these things that you should be able to stock and deploy at will. Just some specifics here. This is getting a little bit into the specifics of design and how we couple these things, but I think it's important we touch on them. You can get up to 6 nano inverters of identical type working in parallel. So if you wanted to do 6 of those 30Ks or 6 of the 60Ks, I mean, 360 kW of 480 volt power, that's a ton of power. You can still do it, but you can't mix and match 30 and 60K. You can't mix and match 480 volt and 208 volt. Just keep that in mind when we're talking about sizing these things. We can put up to 3 batteries of identical type to a single inverter, right? So we haven't even talked about the battery side yet. We'll get into that in a minute, but essentially there's a 40 kilowatt hour option and a 60 kilowatt hour option. As long as they're identical type, we can put up to 3 of those to a single inverter. So, the smallest we're talking would be a 30 kW, 40 kilowatt hour. The largest with just one inverter, no parallel inverters, would be a 60 kW, 180 kilowatt hour. Yes, that's correct. So that's a pretty wide range for working off of just one hybrid inverter. But let's not get it twisted. There are all sorts of different ways you can configure these things. Just keep in note that 2 nano inverters can't share one battery or battery group, right? They all have to have their individual connections to the inverter. You're not going to be able to share power that's connected to one inverter with the other inverter, if that makes sense. But when multiple nanos are working in parallel, you can use one of the inverters without a battery connection. That means essentially you're using it as a PV inverter, right? It has DC coupled inputs where it's going to take that DC to AC. You're using it as a hybrid inverter in that case. But that's totally valid use case if you want to do it that way. Now, okay, we haven't actually talked about the batteries yet, but this screen really breaks down the full system, right? What you're getting from both a inverter standpoint and a battery standpoint. The cells themselves, everything is LFP, 10-year warranty, 8,000 cycles. We can discharge up to 1C, which is great. I think in the past we had typically limited our systems to 0.5C, and in general we are still, trying to limit these systems to 0.5C, but it can discharge at a full 1C. Like I mentioned, the inverter can either be mounted on these outdoor cabinets themselves, or you can unistrut mount it. What you see on the right is the indoor only option, but if I have to level with you guys, especially in California, you're not going to get this thing installed. There's too many hoops that you have to jump through. If you're in an AHJ, a jurisdiction or utility that is more lax on its interpretation of the fire code or keeping batteries indoors, certainly we have the indoor option. But in my experience, 99% of our customers, it's so much simpler to go with the outdoor rated solution because it comes with fire suppression, comes with an HVAC system to help keep the batteries cool. So it's, for most customers, it's a no-brainer. Let's just go with the outdoor rated version. Not to say you can't put that indoors either. With that temperature and smoke sensor control, we can work with the local fire and AHJs. But this, again, from my experience, outdoor mounted is going to save you a ton of time and headache. No need to go to indoor unless it's going to save you a ton of money or headache itself. So this is, again, a breakdown of all the different options that you have. You have inverters on the left, 30K at 480 or 208 volt, 60K at 480 volt. You can pair any one of those inverters with any one of those batteries that you see on the right. But if, say, you go with a 60 kW 480 with a 40 kilowatt hour cabinet, we are going to limit the output of that inverter to 1C. So you won't be able to, you're not going to be able to use the full capacity of that inverter itself. But I could see in a circumstance where, say, you need 40 kW of 480 volt power, 130 kW is not going to do it. You go with a 60, you derate it, we ultimately, reduce its output, and then we can pair it with whatever energy storage we choose to. I think that's a good time to pause. I think we often get questions, and I'm sure if I check the chat, it's in there. Can we pair these inverters with other batteries, like a third-party battery? Or likewise, can we pair your batteries with a third-party inverter? The answer is no. For now, you only can pair these inverters with these batteries. You have to all be within Fortress's ecosystem. And we'll get into some other compatibility stuff right here. Can't overstress the batteries. If you're going to be having multiple inverters that are working in parallel, the battery can't be different than the others. You can't have a 60 on one and a 40 on the other. You want to try and match those batteries with those parallel inverters. And again, it's kind of like tires on a car. We want them to wear at the same rate. We don't want to stress one battery out more than the other. So it's all in the name of wearing the system at an equal rate across the board. And again, back to that point where you can only use this with our equipment. The batteries and inverters have to be operated in closed loop. So if a third party were to come along, they may or may not choose to communicate with those systems. So that's where that comes from. Stay tuned. We may have updates for that as this product rolls out, but for now, it's just closed loop communication with each other. So that is the range, right, that you see at the bottom there. That's the smallest project that you could conceivably do with an eSpire Nano at 26 kVA, 40 kilowatt hour at 208 volt, all the way up to 360 kVA, right? That's 6 of those 60 kW inverters with each of them with 3 of these 60 kilowatt hour battery cabinets for a total of over a megawatt hour of energy storage. So let's be honest, at the larger end of that, you're probably better off going with one of our larger energy storage products, either this eSpire 306 or eSpire Mini. But for the light commercial, it's for the right price, for the right type of customer, this thing blows everything out of the water. And it gives you a ton of different options. These Lego building blocks really make it so you don't have to overprice on battery. You don't have to just say, hey, well, this is the only thing that the OEM's got compared to what you're looking for. We feel confident that we can match just about every configuration out there to get the right price for the customer. So now I want to talk a little bit about the advanced EMS control. So far, everything we've talked about is just using the inverter settings themselves. If you do choose to use our, and with that, you get peak saving based on a kW threshold. You get 6 charge and discharge intervals that you can program throughout the year. But then once you get to this advanced EMS control, we have a matrix that shows you what you're going to get with that. It's an extra piece of equipment. It also comes with an E-gauge meter. If you guys are familiar with E-gauge, it's just a revenue grade meter that's certified by California, Hawaii for revenue grade purposes, used in PPA projects often. So most times, if you're going to be looking to do a PPA project or some type of virtual power plant program, the microgrid controller, the Pro EMS package is going to be required. In addition to that, you get some cool stuff like O&M monitoring, right? We're not going to perform O&M as Fortress Power, but we'll give you this dashboard that says, hey, we're going to send you a notification every 6 months that says it's time to clean your system, right? The O&M schedule is already built into that monitoring portal. And then you can work with your third-party O&M provider, or we can suggest an O&M provider that can help track that on your dashboard itself, and it's just one place to view it all. So alerts and notifications, you're going to get that from both. The number of CTs and what you can monitor increases when you add an E-gauge and microgrid controller. So if you want to monitor in distinct assets, essentially the base package only needs 1 set of CTs. It goes on the main of the facility, and so we know what power is going in and out at any time. If you have a AC coupled solar that you can't use that smart port for, we can use a microgrid controller, and we can use this E-gauge and CTs on that PV to say, okay, what's the PV producing? now I can adjust my battery output based off of that. So that comes with the Pro package, additional monitoring with up to 6 sets of CTs for your site. But I think what's really great is both the energy optimization and the support and services that you see with the Pro package, right? With the Pro package, you get essentially a way to iterate, to make sure that your schedule is set up properly, that your threshold is set up properly to most save the money on your power bill. If you work with our Pro EMS, we're going to be able to go in there and audit and make sure that the rate logic is optimized for exactly how your site uses power. Versus the standard package, it's going to be up to you to say, okay, I'm going to choose to discharge my battery between 5 and 9, or I'm going to choose based on my facility, we're going to choose to, not dispatch any power from 10 to 2 because we have super, high power equipment running at that time. It's the difference between you setting it up yourself and us coming in and saying, hey, let's look together at what you're trying to accomplish and set these parameters, iterate over time to optimize what, your financial outputs. And then on the support and services side, when you purchase our Pro package, you get tier 2 support, right? Tier 1, it's typically a help ticket. We have our people in-house at Fortress in our Philadelphia office who answer these support calls. Tier 2, you're essentially going right to the engineers, the product engineers on the C&I side to be able to help solve these things, hand in hand. White glove approach is really the way I'd put it, right? So it's not needed for every job. We realize that. And I think that was one thing that Fortress Power has changed commercially. I think up to this point, every system we've ever sold came with a microgrid controller, came with an EMS software. Now you have the choice for these smaller commercial projects. It doesn't make sense to add a microgrid controller. If not, you're going to save some money. You're going to save some complexity as well. But if you want, white glove approach, you have a PPA job. If you need to, if you really want to ensure everything is optimized and you get the support that you need for a big customer, consider looking into the Pro package. All right, we've got about 15 minutes left. The last thing that I want to show you guys is what it actually looks like to commission these things. I was blown away. My engineers brought this to Intersolar and did a live commissioning of a system in real time. And oh my God, it is so easy, so quick. So just to give you an idea of what it looks like, I'm going to take you through screen by screen. And this is the process that you as a commissioning, as an installer would be able to commission this thing yourself, if not with just virtual support with a Fortress technician. So you connect, you say, how many inverters do I have? What is my site voltage? What's the frequency? What's the date? Pretty standard stuff. But then you get into, okay, site specific. Is this grid tied or is it fully off grid? What size CTs do we have on the main? Are there any grid parameters, specific to your local utility that we need to be aware of? And then things like, do we have a generator, right? Where is it connected? Do we have a smart load? What is our thresholds to kick the generator on? These are all, very specific things to the site, to the customer that you guys are going to be able, you and the customer are going to be able to change in real time when you commission this and after the fact. So it'll be through a Fortress Power app. This is a little bit different than the commissioning for our Pro package, where we're either sending someone to site or we're working over the course of a couple of days to coordinate all these different pieces of technology. eSpire Nano's commissioning is so much simpler than that. And again, it should be something that you do once, you're going to have a feel for it immediately. So once you've determined, okay, these are my parameters, this is how I'm all set up. Now you can look and see, okay, do I have a charge limit that I want to set? Again, specific to your customer. Maybe you have a storm coming and you want to change the parameters real quick to say, hey, beat up my battery as best I can. So if it does go down, I have, excess power to use. All configurable through the app itself. So again, this is, I think this Nano is a really good fit for this light commercial market where you're trying to get the most cost-effective solution. You may not need all the bells and whistles of a full-blown utility scale system, but you need the cost savings aspect and the algorithms to do it. That's where the eSpire Nano and our Keystone EMS really come into play. So with that, I just want to reiterate, this is our value proposition to you, our partners. We want to take as much of the battery side off your plate as we can. So whether that's helping with Keystone Designer, that 15-minute interval and rate structure analysis, helping look to see what VPP programs are in the area, or helping with on-site commissioning support. Think of this green circle as a menu, right? How can we help secure your energy better? How can we take this stuff off your plate? We're not going to install a system. We're not going to submit for interconnect. We're not going to design the system necessarily, but we'll say, hey, tell me what you're trying to do. Tell me what you're working with. I will mark it up and say, this is our best recommendation. It's based on what you say you want to accomplish. And then the last thing I'll say is if you want us to look at a very specific project, if you're saying, hey, I don't know if this makes sense, we have an intake form. If you go to our website, it's a link under the commercial tab. It says start a quote. We ask for pretty basic info. You don't need to know this stuff it doesn't have to be set in stone or fully perfect. We know this is just a starting point. This saves us about 30 minutes when I get this and I can say, okay, they say they need XYZ. We'll meet for 15, 20 minutes. We'll just go through the list, make sure all of our assumptions are clear. After that, we can turn around a quote in hours, right? If you need a financial pro forma, you need a financial statement, cash flow statement done. That can take up to 5 business days, right? Because then we need to clean the data and make sure all the assumptions are met. There's a lot that goes into that. But if you want us to look at a specific project, start with this online form. We get notified. I'll send you a link to my calendar, and then we're off to the races. So with that said, again, I want to thank everyone for your time today. I'm going to go back through the questions and see if there's anything that I missed or anything that I can answer quickly. Here we go. Do you have software to use, or do we have to send usage information for you to process? Yes. So for now, you'll have to send us that information. We work with a company called Utility API. Essentially, the customer just logs in through Utility API to their utility account and gives us permission to see that interval data. So Utility API has been the best way for us to get that data, but I know for sure sometimes it's like pulling teeth. Even the end users don't really know how to get it. If you are struggling with that, let us know. We can maybe help guide you there. But to answer your question, yep, it's all in-house Fortress Power right now. There's no outsourced software. Is the connection always Y or can it be Delta as well? That's a really good question. It needs to be a Y configuration. It's more stable in that way, but the inverters are set up for 3-phase 4-wire. Must be 3-phase 4-wire. Is the inverter 3-phase, or can it work with 3 phases individually? So technically, yes, you can pull individual phases from the 3-phase output that the system outputs. I would say you really need to balance your phases properly, because if you throw one of the phases out of whack compared to the other 2, the system will fault. So yes, you can, I think build your own split phase system off of this, or single phase system, but just it comes down to you really balancing the loads properly to make sure it doesn't fault out the inverter. Yep, and I see that some of the small shops we deal with have split phase. We need to know. Yep. So I would say let's talk about that. Let's see how we can discuss. Each site is going to be so specific as to what they're trying to accomplish. But yeah, send in one of those intake forms, and we can go from there. And then the last question is, can you send us the presentation? Anthony, I think we'll be able to send that out, no problem. I will send out a PDF version of this. So hang tight. You guys will get that shortly. Okay, great. Let me see if there's any new questions here that I missed. Nope, looks like it. Okay, so we're all good. If anyone has anything else, you have my email there, and also my sales manager's information right there, Matt Ruttenberg. He handles most of the quoting, and I handle most of the single line diagram and like technical review. But together, we're a team here based in Los Angeles that we're here to support whatever you need. So start with that intake form. Send us an email, and we're happy to take a look at your projects and see if they make dollars and cents, see if we can find a way to secure your energy. With that, guys, thank you very much. I hope everyone has a great day, and hope to see you all soon.